Part D, domain. The domain of a function is the set of all x values that can be input to the function. Domain is our way of talking about what sorts of numbers we're allowed to plug in. Most of our functions will have a domain of all real numbers. To write our domains, I want to use our new interval notation, and if I have something whose domain is all real numbers, I'll say the domain is, well, start all the way to the left, negative infinity, and go all the way to the right on the number line, positive infinity, in parentheses, negative infinity, comma, infinity. There are two things we're going to have to look for, though, that might limit our domains. First thing we have to make sure of is that our denominators don't equal 0. We're not allowed to divide by 0. So I need to make sure if I have any denominators in my problem, they don't equal 0. The other thing I'm not allowed to do is take the square root of a negative number. You know that when we do that we get imaginary numbers, but that's not going to have any relevance as far as our graphing these functions are concerned. In fact, we're not going to deal with imaginary or complex numbers at all in calculus. So we need to make sure whatever's underneath a square root is not negative. And actually not just a square root, but any sort of even root. A fourth root, a sixth root, an eighth root. The stuff under any sort of even root must be not negative, must be non-negative. Must be non-negative. So let's take a look at a few functions. First example, I want to find the domain of the function f of x equals 3 plus x times the square root of 2x plus 3. I have a square root here, so I want to make sure the stuff underneath the root is never negative. Well, to do that, I can set up an inequality 2x plus 3 is greater than or equal to 0. And then just solve. X is greater than or equal to negative 3 halves. So I want to talk about all the x values greater than or equal to negative 3 halves. It might help you to draw a little number line to get your interval notation. If you feel like you don't need to do this step, of course that's fine. But all the x values greater than or equal to negative 3 can be represented as, with a bracket, negative 3 halves, comma, infinity, with a parenthesis at the end. Those are all the x values I'd be allowed to plug into that function. Next, let's take a look at the function f of x equals 4 times the cube root of x plus 2. Although you might be tempted to start by saying x plus 2 has to be greater than or equal to 0, sort of like what we did in the last problem, that's not the case here. Because this is a cube root, rather than a square root or fourth root or any type of even root, we don't have any issues with the stuff underneath the root being negative. We're allowed to take cube roots of negative numbers, and we would just get negative answers, as opposed to imaginary answers. Because of that, you're allowed to plug in any x value you want in this problem, so our domain is just going to be all real numbers, negative infinity, comma, infinity. Next, let's look at the function f of x equals 3x minus 4 over x squared minus 6x plus 8. I have a denominator here, and I need to make sure my denominator just doesn't equal 0. I'm going to have an easier time working with this if I factor the denominator, so 3x minus 4 over x minus 4 times x minus 2. And I think x can equal anything except positive 4 and positive 2, because I can't have my denominator equal 0. The numerator can equal 0, that's fine, so 4/3 wouldn't be an issue. X doesn't equal 4 or 2, so let me show this on a number line. And I think anything but 2 or 4 is good, so my number line would look like this. I need to describe this as the union of 3 separate intervals. My domain will be negative infinity, comma 2, in parentheses, union in parentheses 2 comma 4, union in parentheses 4 comma infinity. One more. Let's take a look at the function f of x equals 1 over the square root of 5x plus 7. This function actually has both problems. We have a square root and we have a denominator. Well, because we can't do the square root of a negative number, I want to start by saying what's under that square root can't be negative, has to be greater than or equal to 0. But actually, it also can't equal 0 because this one happens to be in the denominator. So rather than greater than or equal to 0, I just want to make this strictly greater than 0. Now all you need to do is solve your inequality. And we're going to get x is greater than negative 7/5. On the number line it looks like this. So your domain, in parentheses, negative 7/5, comma infinity.